We're given a triangle with some different sides, and we're asked to find the sum of all values of n for which the triangle is isosceles. So we need to look at some different cases. Case number one, let's make these top two sides the same. Okay, that's what we mean by an isosceles triangle. Two sides the same and two angles the same, but we don't know anything about the angles here. I think technically an equilateral triangle is an isosceles triangle, so it might, we just need, we could look into that as well, but I'm suspecting that they're not all going to be the same. Let's take a look. So, right, for this to be isosceles, it must be that n squared plus n is equal to 2n plus 12. We've got a quadratic equation. I can rearrange it to get 0 on the right-hand side. It's going to be n squared minus n minus 12 is equal to 0. And this will factorize minus 4 plus 3. So n is going to equal 4 or minus 3. Right, let's take a look at this. I think it's worth just checking that the sides are now positive, basically. So when n is, and also this is like a little check that it will be isosceles. When n is 4, we're going to get 4 squared is 16 plus 4, we're going to get 20. And yeah, 2 times 4 is 8 plus 12 is also 20. So that one works. I'm going to put a little box around it. And let's check the other one. Minus 3. Now, even though its n is minus 3, that might be okay because I get 9 minus 3, I get 6. And then over here I get minus 6 plus 12, I also get 6. So this is allowed as well. Nothing wrong with that. And we're going to include that in our sum. Let's just check the bottom just out of interest. So when n is 4, I get 12, I get 15. Because we also need to check if the triangle is can be constructed. And actually, I've just realized for this one, I get minus 9 plus 3. I'm going to get minus 6. I have to rule this one out now. Even though it worked, I did get a positive side at the top. I get a negative side at the bottom, so rejected. Right, next case. Let's make this one and this one the same. So now I've got n squared plus n is equal to 3n plus 3. N squared minus 2n minus 3 is equal to 0. Factorize this. It's going to be minus 3 and plus 1. So n is equal to 3 or minus 1. Okay, let's check it out. When it's 3, I'm going to get 12 here. And I can quickly see when it's 3, I'm also going to get 12 over here. And the other length, I'm going to get 2 times 3 is 6, plus 12, 18. Yep, that triangle works. We're okay. Let's have a look at minus 1. So when n is minus 1, I'm going to get 1 minus 1, I'm going to get 0. So, okay, we can also reject this triangle straight away. N is 3. Finally, let's take a look at if these two sides are the same. Okay, so now it must be 2n plus 12 equals 3n plus 3. Then I'm going to subtract 2n from both sides, so 12 is equal to n plus 3, and n is going to equal 9. Let's just substitute it back in and check. Wait, why am I putting 9 in? Put it back in, so it's going to be 2 times 9 is 18, plus 12 is 30. And do that here, I also get 30. Let's just check that other side. We're going to get 9 times 9, 81, plus 9, 90. Now, actually, it might be very tempting to think this is okay, but actually, this triangle, I'm going to kind of rotate it round. If I make this 90 now, I just easier orientation. Now, there's no way that I can have 30 and 30 and for it to meet. So, although these seem valid, this is not not allowed. You've got to be really careful. For any triangle, it must be that if you add any two of the lengths, then they've got to be greater than the other length. This is kind of called, actually, it's called the triangle inequality. So something to be careful of. And in fact, the answer then is the sum of all the values of n is just going to be, it's going to be 3 plus 4, it's going to be 7. Lots of places that you can trip up in this question, but I've tried to guide you through where you have to be careful. I guess the moral of the story is when you're dealing with like equations and solving them, all well finding your solutions, but you've got to, in these cases, check that they are actual physical solutions. So just draw little sketches afterwards. You know, we've got a negative side, and then we've got one here, or we got a zero side, which obviously we rejected, even though it solved the equation. It's not a physical solution for a triangle. And we got this one here where all the sides are positive, but it's not actually, again, a physical triangle.